Hi, in this video we're going to talk about interval notation, set builder notation, and graphs. Now in one of the previous videos we talked about finite sets. Finite means countable values in a given set. We're going to be using interval notation, set builder notation, and graphs to represent an infinite solution. Let's take a look at some examples. All right, in this first example they want us to provide the interval and set builder notation for the following graph. Well, the graph is given right here. And we can see that we have a blue shaded region that starts at -3 and goes up to 7. Now, it's important to note what these symbols mean. We have a bracket. A bracket means inclusive. So it actually includes the value -3 and it goes all the way up to 7. And then a parenthesis means non-inclusive. In other words, the values, the set that we're going to be talking about is any number that's between -3, including -3, all the way up to 7, but not including 7 itself. So it's important to understand we're not talking about the values -3, -2, -1, 0, so on and so forth. We're talking about every number that's in between -3 and 7, including -3. That would be numbers like -2.5, -2.999, 5.3, 5.625. There are infinitely many numbers between -3 and 7. So the interval notation is pretty simple because we use the same symbols that are in the actual graph. So we start with a bracket to mean it includes -3. And then we go to the right all the way up to 7, and then we stop there. So the interval notation is bracket -3, comma 7. So notice for interval notation we have two numbers inside a parenthesis and or a bracket. Now what about set builder notation? Well, set, anytime you think of the word set, you need to think about curly braces. So what we do is this. We start with x. We use a vertical bar. This vertical bar means such that. So this means that x can be any number in a set such that it's in between -3 and 7. Now it's important to notice that I used a less than or equal to for the -3. And that's because we have a bracket there. So if you have a bracket, you want to make sure you include the equal. And for the 7, we do not have an equal under the less than, so that signifies a parenthesis. So once again, an equal a portion of a greater than or equal means it's inclusive. The absence of an equal means it's non-inclusive. So keep in mind, all three of these, the graph, the interval notation, and the set builder notation, are all saying the same thing. They're all identifying the same set of numbers. We can do it graphically by using something called the interval notation or by using what's called set builder notation. So let's take a look at another example. So in example number 2, once again we're looking for the interval and the set builder notation given the following graph. Well, here's the graph. Notice the shading goes infinitely forever toward the left, and it stops as soon as we get up to 3. Well, how do we say this as far as an interval goes? Interval means the left endpoint. Well, this is pointing forever toward the left. Well, the number that we can never get to the left is called -infinity, and when we go to the right, the values are shaded all the way up until we get to 3. Now, what symbols do we use on the end? Because it includes 3, remember, the bracket means inclusive. So we have to make sure that when we're writing interval notation, we use the bracket. Well, -infinity, we can never get there, so we have to use a parenthesis there. So once again, a parenthesis always has to be on whether it's infinity or -infinity. And for the actual number that we can see, it just depends on what's there. It follows what's on the graph. What about set builder notation? Once again, set builder means we use the curly brace. We say x vertical bar. Once again, the vertical bar means such that. And then where is x? the values of x are less than or equal to positive 3. So let me read this set builder notation one more time. X is a member of the set such that the value of x is less than or equal to 3. Once again, all three of these things that we're looking at, the graph, the interval notation, and the set builder notation, are all representing the same values. They're saying the same thing, just in different ways, in different notations. Let's take a look at example 3. All right, in example 3, once again, we have a graph, and we want to write the interval notation. Notice the shading this time begins at this value right here. Now, notice this value is in between negative 1 and 0. So I'm guessing the value would be negative 1/2. That's probably what is assumed here. We don't have any marks to signify that, but that's where it looks. It's exactly in between negative 1 and 0. So we'll say negative 1/2, and it goes to the right forever. Notice once again that the interval notation, we have two values separated by a comma. The left endpoint, if you will, is negative 1/2, and it goes to the right forever, so that would be infinity. The whether or not it's a bracket depends on whether or not the value is inclusive. For the interval notation, we see a parenthesis. The parenthesis that we're looking at in the graph is non-inclusive, so we use a parenthesis. And on infinity, we can never get there. Therefore, it is also a parenthesis. So just remember, infinities always have parentheses on them. What about set builder notation? Well, x is any value such that the x value is greater than negative 1/2. It's greater than because the values are shaded to the right of negative 1/2. So x belongs to the set such that its value is greater than negative 1/2. All right, let's take a look at example 4. Now, number 4 gets a little bit tricky here. Let's look at it. We have two shaded regions, and that means that x can belong in either one of these two shaded regions. So in other words, we have two intervals that we have to look at. We have to look at the one that's on the left-hand side and the one that's on the right-hand side. We have to describe both of these. So let's start off by describing the interval that's on the left, if you will. So notice the arrow points forever to the left, so that's negative infinity. It goes to the right, and it eventually stops at 0. Notice the symbol on the right, the grouping symbol we use, is a parenthesis because it's non-inclusive of 0, and negative infinity always will have a parenthesis on it as well. But then we have to also describe the values or the numbers that's in the right region over here. So how do we do that? Well, where does it start? It appears that it's exactly between, 3 and 1/2. So we're going to say it begins at 3 1/2, and the arrow indicates that it goes forever to the right. That would be infinity. So now we have to include the symbols. It is inclusive because it's a bracket. It includes 3 and 1/2. It goes to the right forever, so that's going to be a parenthesis. Now we'll look at this more closely in just a few minutes, but we need to use a symbol between these two sets to describe that it's in one or the other. So what we're going to do is use what's called the union symbol, which means or. So the values of x will either be in the set on the left or it will be in the set on the right. So this is the interval notation that's equivalent to the graph that we have listed above. Now, what about set builder notation? Well, once again, we have to describe both regions, the shaded on the left and the shaded on the right. So how do we talk about the shaded region on the left-hand side? Well, x is any value that's less than 0. Then we use the word or, and then we say for the right-hand region, x is anything greater than or equal to 3 and 1/2. Now sometimes instead of saying 3 and 1/2, they'll use something like 7/2. 7/2 is the same thing as 3 and 1/2. All right, let's take a look at example 5. It's going to be just a little bit different in the question that's being asked. This time they're giving us the interval. So it says provide the graph and the set builder notation for the following interval. Well, the interval is listed like we see here. Well, it's easy to go from the interval to the graph because it tells us where to start. This is the left start point. So we start at -6, and it is a bracket, so we have to use a bracket, and it goes to the right forever. So what we're going to do then is just simply graph that by shading like this, and then just putting an arrow on the right that points to the right forever. And what about the set builder notation? X is anything such that x is greater than or equal to -6. Notice how important it is that I include the equal under the greater than. It's because of the bracket. All right, what about example 6? They give us an interval negative infinity to +2. Well, the left endpoint is -infinity. That means that this graph is going to be pointing to the left forever, and it's going to eventually stop at the right endpoint of 2. So let's put the right endpoint of 2, and notice the right endpoint has a parenthesis that opens to the left, and then we just simply shade forever to the right and make sure we put an arrow that indicates that it goes forever to the left. As far as set builder notation goes, x can be anything such that the value of x is less than +2. Notice this time we do not include the equal under the less than because it is a parenthesis, which means non-inclusive. All right, one more example, example 7. In example 7, this time they're giving us the set. We have the set which says that x is any value such that x lies in between -3 and 5, and notice the equal means it includes -3 itself. So how do we do that? We start at -3 with a bracket, and then we go all the way up to +5 and put a parenthesis. Again, it's a bracket because of the equal. There is no equal, therefore it is a parenthesis on the right endpoint, and then all we do is connect the two, like this. Okay, so this graph goes from -3 all the way to 5. It includes -3, but it does not include 5. As you can see, there is a mistake here that's made. It's saying set builder notation. This actually should say interval notation. So we're going to take care of that now. What about the interval notation? Well, that's easy. It goes from -3, all the way up to +5. The bracket and parentheses are important. The brackets tell us it includes -3, and the parenthesis tells us that it does not include +5. So once again, the interval notation is bracket, -3, comma, 5, parenthesis. Once again, all three of these are saying the same thing. They're all talking about the same set of numbers, whether we're talking about the set builder notation, the graph, or the interval notation.